I'm Hashi Yashati Mendoza, a grade 11 student from STEM 1H. So now I will show you how to solve the extrema of these given functions and interval values. F of x equal x plus 1 over x and the interval values from 1/2 to 2. Before to get the extrema of this given, we need first to get the critical points. To get the critical points, we need to derive this function. So, to derive this function, we will use quotient rule. Quotient rule says that you need to copy the denominator and derive the numerator, then subtract. Like, copy the numerator, then derive the denominator, and subtract. It's like an alternating process. And square the denominator. As I said a while ago that we will use the quotient rule in this given. So this is the derivative of y with the respect of x. So let's copy the denominator and derive the numerator, then subtract. And square the denominator. Simplifying further, we can observe that we cancel out the x here. So what we have left now is -1 over squared. Next thing to do is we will equate the first derivative to 0. So, and we will use cross multiply. -1 will never be unequal to 0. So it means that we don't have critical points or no CP. Since we don't have critical points, so we don't have any values that going to add up aside from these interval values. So the next thing to do is making a table. In making a table, we will plug in the interval values to the given function. So our table will look like this. So this is our table. To plug in the originality of the function of x plus 1 over x, we will get the 1/2. So 1/2 plus 1 over 1/2 is equal to 3/2 over 1/2. Simplifying further, 3/2 to 1 is equal to 6, 2, or 3. So, we will put the 3 here. So, in the next interval, the same thing as what we did in this first interval. So, 2 plus 1, 2 is equal 3/2. So, the 3/2 we will put here. Since we have only 2 values, we can now conclude that our maximum is equal to 3, which is the highest one. So, max is equal to 3. And for our minimum is 3/2, the lowest one. So, our mean in any case, this is the extrema means, getting the maximum and minimum values of the function. Like extrema in calculus, any point at which of the function is largest or smallest. For the rest of my life, say yes, 'cause I